In the last video, we saw how to import data from Excel into MATLAB. And we saved the imported data as vectors or arrays. And then we saved them into .mat files. You don't need to save the files as .mat files to work with them in MATLAB. It's enough to just import them to the workspace and start doing your work from there. In this video, we're going to explore another type of arrays that is called timetable. So to know more about the timetable class, or to know more details on how to use it, you go to doc and then timetable. I've already entered this command and here's the documentation. Now let's explore this timetable class. In this type of array, we have time-stamped rows, and then we have other variables. For example, here we have 2 columns, and each column represents a different variable. This class or this array holds synchronized maternal and fetal heart rates. This means that the data was measured or recorded together at the same time or simultaneously. Now, how can I access different variables or different vectors in this timetable class? Let's say that I want to access the time vector. What I need to do is do tt.time. This will print the whole vector, which consists of 233 rows. Okay, so if I hit enter now, it's gonna print this vector. As you can see here, you have the whole vector. If I wanted to get the first 2 values of the time vector, I can do this tt.time. I want to see from 1 to 2, and here it printed the first 2. Notice now we have a third type of array. Now when we extracted the timestamps, it saved them in a duration array. Here, class duration. We will discuss that soon, but here, let's say I want the first 3. What do I do? 1, 2, 3. Here we are. Now let's call this, just to make things easier, let's call this fetal, and let's call this maternal. Okay, let's say I want to see the first 2 values of the fetal data. What do I do? The name of the timetable, which is tt.fetal. The case of the letters matters, so if I write a capital letter F here, it's gonna give me an error. It's not gonna work. So I want the first 2 values. This is how I see the first 2 values of the fetal data. Again, same thing. If I want to see the first 2 of the maternal, or let's say I want to see from 2 to 4. Here, it's printing all the values 2, 3, 4. Now let's go back to extracting the time vector. Let's say t equals tt.time. I want a number. I don't want it as a duration array. I just want it as a number array, or a numbers vector that only has the values with no time units. What do? There's a command called seconds that turns the duration array into a number array of the corresponding seconds. So let's do that. So I called it here, I called it t, right? Duration. So now let's call it t2. t2 equals seconds t. Now it has all of the values, but we lost the second label. Okay, I just want to show you, but it's scrolling super fast. Okay, here 0, 0.25, 0.5, all of our values. Now it's obvious if you want to determine the sampling frequency or the sampling time, sampling period, just looking at the vector of the at the timestamps or the time vector, you can see that the sampling period is 0.25. Okay, here the difference is 0.25, the difference is 0.25. So I can see from those first few values that the difference is 0.25, and that's the sampling period. But how can I verify if the difference between all of these values is 0.25 of all of the consecutive values? There's a vector or there's a command called diff. So do doc diff here. What does it do? It takes a difference calculates differences between adjacent elements or consecutive elements. So if I just do diff t2, I'll get a vector, and it's showing me that all of the values are 0.2. So instead of, if I had a lot of values, much more than 233, and I don't want to, or I don't have time to scroll through all of them and see if the difference is indeed 0.25, what can I do? I can do difference of the difference between the values of t2. What does this mean, difference of the difference? So when I did it the first time, difference between t2, the values of t2, I got a vector of this difference, right? I want to take the difference between the values of this result. So I do it like this. It should, if the sampling period is constant or the time step is constant, then difference of the difference of t2 should give me zeros. Again, let me repeat. If I do difference t2, I got this value, these values, right? If I do difference again for these values, then I should get 0. Why? Because there's no difference between 0.25 and 0.25. The difference is 0. Okay, so let's see. Indeed, I got a vector of all zeros. I can do it another way. Difference t2, then 2 directly, instead of doing difference. So it means, first of all, take the difference between the values of t2, and then take the difference between the values of the result. Again, the answer is all zeros. Going back to the fact that I don't want to scroll up or down and see all of the results, what can I do? I can do this. Type diff t2 second order equals to 0. Okay, this is the first step to see if it's true. If it's true that the difference between the second order difference between the values of t2 is 0. If my answer is, if the condition is satisfied, then I'm gonna get a vector of all ones. And here we are, we got a vector of all ones. Now we can use another command, check it out, doc all, and you can see it determines if all array elements are non-zero or true. Okay, so if I do all diff, so again, I told you I want to get one value, not a vector. Okay, t2 2. I want to see if this condition is true. When I did only this, it told me that yes, it's true for the first value, it's true for the second, it's true for the third, it's true for the fourth. But I just want to see if it's overall true. Then I'm just gonna say, let's call it is it constant? All difference t2 second order equals to 0. Is it true? Is it true? Yes. Is constant is 1, which is true. 1 means true, 0 means false. So now I have checked that the sampling period is constant, and I didn't need to scroll through the vector of the extracted vector of time and or the vector of the difference. Okay, so we're done from, so in the last few minutes we were discussing how to convert the time vector into or the duration vector into a vector of numbers, and then we verified if indeed the sampling period is constant, which is 0.25. Now if I want to get the value of if I want to save value of TS, what can I do? I can say TS equals, how did I know the value of TS? By doing the difference once, right? Difference T2. But again, it's gonna give me a vector, right? A vector of the value of TS, like 0.25, 0.25, 0.25 for 233 times. I'm just gonna take the mean to take what? The mean, what is the mean gonna be if all the values are the same? It's gonna be one value. Okay, in this case, TS, mean difference of the values of T2, it should print 0.25. And here you go. TS is 0.25. It's saved for later use. Overall, in this video, we looked at how to use the timetable array, how to extract different variables, and specifically we spent a lot of time on how to extract the time vector. We extracted it first as a duration vector, and then as a number vector, and then finally we determined if the sampling period is constant and what is the value of the sampling period.